All right. In this chapter, we're going to talk about acids and bases. And the first acid-base theory we're going to talk about is the Arrhenius acid-base theory. So Svante Arrhenius in 1887 defined the following. An Arrhenius acid increases the concentration of H plus in aqueous solutions. So the thing to remember with this is it's increasing the concentration. Remember, concentration is the amount that you have in a given volume. So if you're increasing that, that means you're going to be making more of these H pluses. And this is kind of the takeaway. So whenever you think of Arrhenius acid, think of it produces H plus. A base, on the other hand, an Arrhenius base, this increases the concentration of OH minus in aqueous solutions. So if you remember back when we talked about aqueous, this is something that's dissolved in water. So both of these happen in solutions. The takeaway for an Arrhenius base is that it produces OH minus. All right, so if you see Arrhenius base, think that it produces OH minus. All right, so we're going to go into two examples of this. One is with HCl and the other is NaOH. So for HCl, let's say we had a little beaker, and in our beaker we put some water because, again, it's in an aqueous environment, right? So here there's some H2O floating around, all right? And then we're going to drop in some of this HCl. Now, something special happens when you drop in HCl into water, and that special thing is that it breaks apart, or another word for it is it dissociates. All right, so HCl is going to break apart, and what's it going to break up into? Well, if you were thinking about like the nomenclature chapter, you might remember that H is usually +1, and if you look at your periodic table, you'll see chlorine that's in that group 17, it's usually -1. So that's actually what it's going to break up into when it falls into this beaker, or we put it in the beaker. So we'll have some H pluses floating around, and then we'll have some Cl minuses. Now, if we have a bunch of HCl that we're putting in here, then there's going to be a bunch of these H pluses and a bunch of Cl minuses. So we'll have all these H pluses floating around. And another interesting thing that could happen is sometimes an H plus and an H2O get close together, and they'll actually form this H3O ionized molecule. And in this chapter, we'll just assume that anytime you see H plus, it could also be an H3O plus. We're kind of ignoring water in this chapter because most of these things are happening in water. All right. Now, if we go back to this whole question of, all right, what's an Arrhenius excuse me, what's an Arrhenius acid? Well, it says that it produces H plus. And if you look here, look at all these H pluses that we have in this solution. So this one would be an acid, and that's what we would think of as HCl here. It would be an acid. Now, from nomenclature, you already knew that it is an acid because there's an H in the front, right? And most of the time when you see an H in the beginning, that means it's going to be an acid. And we're going to even know how to name it because of the acid rules, right? Where this is hydrochloric acid, okay? So we're going to use all of these context clues to figure out what if something's an acid or if it happens to be a base. All right, let's look at the sodium hydroxide. So over here, we have another beaker. I'll make this one a little bigger, just so it's easier to draw. And in here, we'll have a bunch of water. And in this one, we're going to drop in NaOH. Now, you see some things here, right? You see it's a sodium. And then if you remember OH, that's a hydroxide, right? From when we were doing nomenclature as well. And there was a hint to it right back up here, right? It says it produces this OH. So what's going to happen here is this is going to break apart. And as you probably guessed, the OH is going to be negative, OH minus, because that's what hydroxide was. And then Na, if you look on the periodic table, what's the charge of that one? Yeah, exactly. It's Na plus 1, exactly. So when we put this into the water, you're going to get a bunch of Na pluses and then a bunch of OH minuses. Now, if you put a lot in here, you'll have a lot. If you only put a little, you'll have a little. But either way, if you put any of this in the water, it's increasing the amount of OH minus. So this is going to be a base because we have more OH minus in there. And this one's going to be an acid because there's going to be more H pluses. All right. So here's this fun fact that has the wrong letter on here. That should be an E. It says, fun fact, H plus combines with H2O in water, making H3O plus. So you can write H plus or you can write H3O plus in this chapter, and they mean the same thing, okay? So throughout this chapter, you'll see this sometimes, and you'll see this some other times, and they're basically interchangeable, all right? Because again, there's a lot of water in the background of here.